To kind of give a broader perspective of where we are in terms of our climate, our next speaker is going to look more at the trends in the data that kind of underline these problems or underscore the problems that we're now facing with a changing climate. And so our next speaker is Sherry Godlewski from New Hampshire DES. So this session is trying to help us connect the extreme weather events and changing climate conditions that we're seeing around us now. And Sherry's going to present trends and information that make that connection as to how global changes impact us locally. So local data from the New Hampshire climate assessments and predicted future trends will be presented. Sherry has worked here at DES for over 20 years and has experience in water, air, waste, and environmental health programs. Currently, she serves as the Resilience and Adaptation Manager at DES. Sherry is the co-chair of the New Hampshire Coastal Adaptation Work Group and a member of the Upper Valley Adaptation Work Group. She has an MS degree in Environmental Communication and Administration from Antioch University. I think Sherry is all queued up and ready to go. So Sherry, if you're there, take it away.
All right, can you guys see my slides?
We can.
All right. Hi, everybody. Thank you for being a part of today's conference. Today, as Pierce said, I'm going to help make the connections to what we're seeing around us and how they are indicators of climate change, as well as bring in some global reasons for why we're seeing these impacts. So first, let's take a look at last year. Last year, we had a record number of over $1 billion weather events. We had 22 separate events that cost over $1 billion to recover from. It cost $95 billion in total to recover from these events. You can see the number of hurricanes that we had in the southeast, as well as some of the severe weather events in the Midwest, fires in the West, as well as drought and heat waves. So this is pretty significant, and it's the 6th consecutive year where we've had 10 or more of these billion-dollar events. Now, to bring it down to New Hampshire, you can ask yourself, you know, I've lived here a long time. We've seen some of these, and it's true. If you look at the 50-year period between 1953 and 2002, in that 50-year period, we had 15 disaster declarations and 3 emergency declarations. But if we look into the more recent past, in the 16 years leading up to 2018, we had 21 disaster declarations of various types and 10 emergency declarations. So we're seeing these at a more frequent event, and they're very inconvenient, and they're also expensive. This slide shows what we have requested from the federal government to recover from these events. And I've normalized these dollars to 2017 so we can compare apples to apples. Many of us who've lived here a while remember the 1998 ice storm. That was a huge event for us. But what we can start to see here is starting around 2005, we're seeing almost an annual pattern where we're asking for federal dollars to recover from these events. And they do provide us money, but it's only a 75% amount. And so we have to come up with match. So it costs New Hampshire money to recover from these events as well. Now let's take a look at how this year started out. This image is of our mean temperatures for this winter. And I want to acquaint you to the color scheme of these next few slides. Anything that's white is near average. Anything that's light pink to darker pink is above average to warm, record warmest. Anything that's blue to darker blue is below average and record coldest. So you can see that for this winter, we were much above average in some areas of the state in terms of our average temperature and above average for the rest of the state. So we had a warmer winter. In terms of precipitation, a similar type of color scheme, you can see that most of New Hampshire was much below average in precipitation this winter, and some areas were below average. So we were warmer and we were less wet. So now let's talk about what happened in February, not the whole winter, but what you can see in February, and this is the same kind of color pattern that you're seeing, but we're looking at land and ocean temperatures. So it's important to note the ocean temperatures as well. But what happened in February, if we look at February just by itself, we were unusually cold in North America and in northern Asia, while other parts of our planet were much, much warmer. And what happened in February is we had that huge Arctic blast. You'll all remember this because it was very cold here and we had some good snow. I like winter. And you can see that it was all through our area in northern Asia. And remember that the cold that happened in Texas causing huge problems for that state. So while we had this huge Arctic blast, a lot of the planet was much, much warmer. And this is a symbol of climate change, and I'll talk more about it. But let's talk about heat. And this is my cat, Rudy, and he weighs 16.7 pounds, and he thinks our summers are way too hot. And you know what? Rudy's right, because we're seeing increasing number of days over 90 degrees that are happening here in New Hampshire. But more significantly, we're seeing our nighttime temperatures increasing at a faster rate. Between 1940 and 2017, minimum temperatures have increased by 2.5 degrees Fahrenheit. That means the lowest we go is now 2.5 degrees higher. This reduced nighttime cooling can have very serious health effects, especially if you live in a densely populated area. Last summer, Concord had its 4th hottest summer on record with 25 days above 90 degrees, while Manchester had 32 days above 90, a whole month above 90 degrees in New Hampshire. And those hot days are coupled with crushing humidity, and all indications are that this is not going to change. We're going to continue to move in this warmer than average direction. And in terms of humidity, we've already seen a doubling in these high humid days that we're experiencing in the Northeast. And we're not used to that. We're not used to high heat and humidity. So it's challenging on our bodies. So, and then last summer, during the period between June and summer, the Northern Hemisphere had the warmest summer on record. And you can see New Hampshire had some record warmth in the southern part where the rest of the state was much above average. And when we have these really long periods of heat, it can create problems for the Arctic. And the Arctic is warming faster than the rest of the planet. And last year, we had the second lowest sea ice extent on record. The record low was in 2012. I don't know if you'll remember that, but we came very close to that record low. And why this is significant is because when the Arctic sea ice is in place, it's white. And when the sun hits the white ice, it's reflected back out into the atmosphere. But as the oceans warm and our average temperatures are warmer, that sea ice is melting, opening up and showing the ocean, and the ocean is dark. So when the sun hits the ocean absorbs that heat, and it creates this feedback loop where the ocean's getting warmer, it's melting more ice is melting, it's allowing the ocean to get warmer. So this is something that scientists are watching, and these lowest extents are all having had occurred in the last 14 years. And then by the end of October last year, Arctic sea ice still had not formed off the coast of Siberia, and that's the latest date on record. So scientists are paying a lot of attention to Arctic sea ice. Now let's come out of the Arctic and be in the 48 states down here. What you see in the image on the upper left is the wildfires that happened in California. And when I saw this image, I was so shocked because you can see that the wildfire smoke moved all the way across the country and it impacted our skies. But what I also was shocked at, while we're having these huge wildfires with smoke moving across the entire country, we have these 2 hurricanes brewing in the Atlantic. So these wildfires are very, very impactful where they are, but they also cause huge air quality issues. And this shows the type of air quality that existed in this region during the fires. And you can see the various colors are represented by different types of air quality: moderate, unhealthy for sensitive groups, unhealthy, very unhealthy, and hazardous. There was hazardous air quality in this area for a very long time because of these fires. And in New Hampshire, when we call an air quality action day, it's usually when we're in the orange and we suggest to reduce prolonged or heavy exertion. We've not seen red, purple, or dark purple in New Hampshire, thankfully. But these people in this area couldn't really go outside, they couldn't really exercise because they were impacted by poor air quality that's associated with those big wildfires. And you may not think of New Hampshire as a state that sees wildfires, but last year we did. We saw over 200 fires, and in the White Mountains, the fire chief was talking about a fire that had burned 2 feet down into the ground because there was no soil moisture. And we're currently in a situation where we are in a high fire danger right now. At the end of September last year, the governor issued a proclamation to ban outdoor burning and smoking near woodlands to prevent future wildfires. So pay attention out there and be careful. And of course, this is where we go. We get set up for drought. When we're warmer and we're not as wet as we're used to being, we get into these situations that many people have talked about here today. Here's the drought in last November, where we had extreme drought in this area of the state. This area had severe drought, while the rest of the state was in moderate drought. And all these dots indicate water restrictions. And you folks know more about water restrictions than I do. And then at the end of the fall, DES issued a press release saying, you know, we may have a multi-year drought as we head toward winter unless we get more precipitation. And in fact, we are still seeing areas of the state that are in drought. And what's significant about this map is the S and the L. S is short-term drought and L is long-term drought. And long-term drought is typically longer than 6 months, and it impacts our hydrology and our ecology. So we're seeing this in New Hampshire, and it's pretty significant, and it's dry out there, and you all know this. But it's interesting to look at the whole country, because a lot of the country is in drought, some form of drought, except the Southeast, right? And what happened there? These are the folks who are impacted by all the hurricanes. And the 2020 Atlantic hurricane season was the most active and 5th costliest Atlantic hurricane season on record. We had 30 named storms, 12 hit our country. We ran out of names for them. We had to go into the Greek alphabet. And the other thing that was significant about last hurricane season was that we had the latest Category 5 storm ever. Usually those big storms don't come in mid-November. They come earlier in the season when it's warmer. And so these hurricanes are being fueled by warm ocean and sea surface temperatures, which are indicators of a warming planet. And there's this new science called attribution, where scientists can now link these extreme weather events to carbon dioxide in our atmosphere from the burning of fossil fuels. So the more carbon dioxide we have in our atmosphere, it boosts these odds of these extreme weather events that are hitting us here in New Hampshire and around the entire globe. And Hurricane Florence in 2018 was the first hurricane ever forecasted with an attribution statement. And in their forecast, they said that the storm will be approximately 80 kilometers in diameter larger at landfall because of human interference in the climate system. And it was. And when they did these retrospective analyses, these statements were holding up. So this science of attribution is something that there's a lot of public interest in to help us understand how we're influencing our systems. So let's just take a step back and talk about weather versus climate. Weather is the set of conditions at any point in time, right? Yesterday it was partly cloudy, today it's mostly sunny and a little bit warmer. When we talk about climate, we talk about the average set of conditions over a period of decades. We look at 30-year averages to think about climate. So you can think about this as climate is your wardrobe, whereas weather is what you have on today. And this is how it happens. So the sun comes down and heats our planet, which is good. It allows us to live here, and then it bounces back out into space. And our planet is surrounded with a blanket, and this blanket is made up of various gases. And when we burn fossil fuel, we add gases to this blanket. We add greenhouse gases, carbon dioxide, methane. And when you put more and more gases into this blanket, it makes the blanket thicker. And it's just like if you were in bed and you added a quilt to your bed, you might get warmer and you might get a little bit sweaty. And that's what is happening to our planet. And over the past 50 years, the average global temperature has increased at the fastest rate in recorded history. And the burning of fossil fuels for transportation is the largest source of this heat trapping pollution. Electricity is second. And that just switched in 2016. Before 2016, electricity generation was the #1 source of heat trapping pollution. But what has happened since 2015 is we switched to more natural gas fired electricity generation. We've got more renewables online, and we have a lot more efficiencies. So now transportation is the largest source of these greenhouse gases. So this global warming causes the climate to change. Those greenhouse gases trap heat, they warm our atmosphere, change water cycle, warms oceans, melts glaciers, causes sea levels to rise, and it affects plant growth. And this all started during the Industrial Revolution, right? We became very mechanized. We were using fossil fuels to move things faster and quicker, and it was a revolution. And from that time, we have changed the amount of carbon dioxide in our atmosphere from 280 parts per million to where it is today at 421 parts per million. And we know this because we can measure carbon dioxide. And this is Dr. Cameron Wake and his team from UNH in Nepal, and they're drilling down through the glaciers and pulling out these ice cores. And they pull these ice cores out and they do analysis. They can do thin sections or they can melt them to understand what the components are. But this is an example of a thin section where they've cut this ice core in a very thin section, looking at it under a microscope, and all those black blobs are the concentration of carbon dioxide in the atmosphere when that layer of ice was laid down. So we can learn a lot about our history when we look at ice cores that are drilled down through all these layers of ice. And then we also are doing ambient monitoring or background monitoring at Mauna Loa in Hawaii, where we've been collecting data there since 1956. So we know what our current carbon dioxide levels are in the atmosphere as well. And there's other ambient monitoring stations around the planet, not just at Mauna Loa. So now let's pretend we're looking down one of those ice cores, and we're starting at the level of the Industrial Revolution, and we're looking back in time, 400,000 years. And this axis represents the carbon dioxide concentration. So you can see that there's some natural variation to carbon dioxide in our atmosphere. It peaks and it decreases. But what you can see is it's never really gone above 300 parts per million back 400,000 years ago. And as I said, at the Industrial Revolution, we were at 280 parts per million, and here we are today. We're at 421 parts per million. We have not seen this level of carbon dioxide in the atmosphere going back 400,000 or even farther. And if you think that's interesting, which is even more interesting is when you overlay temperature. There's a very strong mirroring between carbon dioxide and temperature. When the carbon dioxide is high, the temperature's high. When the carbon dioxide is low, the temperature's low. And these 4 periods of low carbon dioxide are our 4 past ice ages. And so what you can expect looking out into the future, if this is where our carbon dioxide levels are, we're going to expect to see our temperatures mirror that large amount and become warmer. In fact, the 10 hottest years on record globally have all been since 2000. And 2020 snuck in there right behind 2016. So last year we had our second hottest year on record. And then in Concord, when you look at decadal records, so for every 10 years, what you're seeing is a decrease in cold records in each 10-year period and an increase in warm records. And in 2020, we didn't have any cold records. We had all record highs. So as the planet warms, it doesn't do so uniformly. And it's important to note that the temperature at the Arctic compared to the temperature at the mid-latitudes is what governs the flow of the jet stream. So it keeps the jet stream in a tight, predictable pattern, keeping the Arctic air up in the northern latitudes and the warmer air in the mid-latitudes. But because the Arctic is warming 3 times faster than the rest of the planet, the temperature difference between the Arctic and the mid-latitudes isn't as great. And so that causes the jet stream to become very unpredictable and very wobbly. And it can bring cold air masses down into our area, which we just talked about in a previous slide, while pushing warm air masses into areas that don't usually receive them. And we first talked about this as the polar vortex back in 2015 when we were really, really cold and we had tons of snow. And Alaska was really, really warm and they didn't have much snow. They had to move the Iditarod dog race farther north and they had to truck in snow for the start. So this temperature differential that's decreasing because the Arctic is warming so fast is causing the jet stream to wobble and stick in these patterns that can sometimes be long, cold winters. So sometimes a long, cold winter can indicate a climate change issue. And this is what happened in February with the polar vortex, when Texas had those huge impacts and it was really, really cold in this part of the United States. But look up in here how warm it was in the Arctic and Greenland. So that's the February polar vortex. Now, this changing jet stream also exhibits extreme behavior in the summertime. And during the summer, because warm air holds more moisture, when it's stirred by a hurricane, the moisture manifests as intense rainfall. And we saw that in Hurricane Sandy and Hurricane Harvey and many of these hurricanes where they're getting like 60 inches of rain in one event. So it's the same phenomena as the polar vortex, and it's predicted to increase by 50% this century if we do not get our greenhouse gas emissions and carbon dioxide specifically in check. So we are altering our atmospheric currents. Now let's talk about our ocean currents. First, let's look at this image. And you can see in general that the ocean has warmed compared to the temperature change since 1870. We're a little bit warmer than we used to be. Now, let's pay attention to this ribbon. And I want you to think about this ribbon as a conveyor belt. And what happens in this system is warm surface waters are moved up into the northern Atlantic, where usually they're cooled. And cold salt water is more dense than warm salt water. So that cold salt water would sink down and form this deep ocean current of colder water going back to the lower latitudes and keeping this system moving. But what's happening is because the Arctic and Greenland are melting so much, they're contributing cold, fresh water into the system. So when this warm salt water comes up, it's getting diluted and it's not able to drop down. It's not as dense as it would be if it wasn't diluted. And so this whole current is very sluggish, and it hasn't been this sluggish in over 1,000 years, and it's a new record low. Scientists are very concerned about this, and they're watching this because the Gulf Stream governs a lot of things in our Earth system. And you know this if you've gone swimming in the ocean the past few summers. The Gulf of Maine is much warmer. You can actually swim in the ocean off the coast of New Hampshire or Maine. And so the Gulf of Maine has been warming 7 times faster than the rest of the ocean in the past 15 years. And it's because these warm surface waters are being brought up here and they're just sticking in place. So we're also altering the flow and the patterns of our ocean systems. Poll question number 1. I'll give it to you, Liz.
Okay, so the poll question is, a cold and snowy winter in New Hampshire can be an indicator of climate change. No, because climate change is only making New Hampshire warmer, or yes, we get Arctic blasts due to a wobbly jet stream. Okay, so most folks are attributing the snowy winter to the wobbly jet stream. Sherry?
Awesome. Yeah, great job. All right. Now let's come a little bit more locally and talk about the local and regional climate assessments that have been done for New Hampshire. Dr. Cameron Wake out of the University of New Hampshire has put together these local climate assessments, and I'm going to talk about the southern and northern ones and future projections, but I'll give you some highlights from these climate assessments. The first thing we already know that we've experienced is an increase in precipitation in both rain and snow and the amounts and intensity. So now when we're getting these storms, it's really raining or snowing hard. It's not like usually the gentle summer rain. We've already seen an increase in average temperatures. We all have talked about the increase in extreme weather that we've definitely seen. We're seeing changing seasonality. Our falls don't happen as early as they used to, and sometimes our springs come in a little bit earlier. We're seeing periods of drought, as has been discussed already today, and then we are seeing sea level rise. In Portsmouth, the sea level has risen 8 inches between 1912 and 2018. We have weekly high tide flooding in Hampton, where the streets are flooded and people can't park their cars there. And as sea level comes up, so does groundwater. So we're seeing an increase in groundwater levels. So let's see some illustrations. So we've already seen a 71% increase in heavy precipitation in the Northeast. We're seeing warming that's pretty significant. In the northern part of the state, we've seen warming by 5 degrees in the winter on average, and in the southern part of the state, about 4 degrees on average. seeing periods of drought, as we've all talked about. This is the drought from 2016 with the water restrictions. And then we're seeing sea level rise. These are images taken on a king tide, which has nothing to do with climate change. It's just some of the highest tides of the year. And we try to capture those in photographs to help us understand what our future might be like. And here's Hampton with a flooded street. It's a beautiful day. There's no storm there. It's just a high tide. And here's Portsmouth, where the water is right up to the back of these houses. And April mentioned her allergies were really bothering her. And April, that's because we have a longer allergy season now. We've already seen an increase from 13 to 27 days of ragweed pollen in the Northeast. And ragweed loves carbon dioxide, so it produces more pollen per plant. So we have a longer season with more pollen per plant. So that's why April isn't feeling so good today. The other thing you may have noticed in your own backyard is that poison ivy loves carbon dioxide, and it's growing bigger and it has more toxic oils. So be careful out there when you're playing in your garden or especially near your stone walls. We're also seeing ecological impacts. I'm sure many of you had heard about the impacts to moose from winter ticks. Because of the warming, it's not getting as cold. Ticks are able to live year round. When birds migrate back into New Hampshire, sometimes their food source isn't available because they're coming back a little bit earlier. And then we're seeing these pests. This is the emerald ash borer. We're also seeing other pests that are impacting the ecology of our state. And then we talked about the ocean species or the ocean warming. So we've seen a change in ocean species. Cod have moved north due to warming. Lobster have moved north due to warming. We still have a robust lobster population, but the southern New England states don't have that as much. The shrimp population collapsed in the Gulf of Maine in 2013, and it hasn't come back. And our clams and our oysters are getting more contaminated due to the increases in rain and bringing pollutants into the clam flats. And then their shells are being impacted by ocean acidification. So we're seeing impacts that are impacting our economy because we have a very natural system economy in our state. And so a lot of these industries that are listed here are being impacted by the changing conditions in our climate. And so I just want to take a point to say climate change is real. 99% of all climate scientists agree that these climate warming trends are likely due to human activity, and it's already occurring. We already seeing it in our communities, and these extreme events damage critical infrastructure, which you all know. It impacts our economies and the vitality of our communities. So what do? Well, we can do nothing and just hope for the best, or we can start to do what you people are already doing. You're doing things to reduce your fossil fuels, to mitigate the impacts of climate change. You're having efficiencies at your systems. You're also installing solar panels. That's great. Keep going. And then we all need to adapt. And it sounds like many of you are. We need to prepare for the current and future impacts in order to be viable. And we've heard a little bit about drinking water systems, but I just wanted to highlight some of the drinking water system issues. And flooding is something that many of you talked about impacting infrastructure. And you can see here, this well in Conway, this well house is designed to be resistant to flooding, but it can't be resistant to flooding when flooding is at its door. So this erosion was pretty impactful for this particular system. We also talked about impacts from pollutants like bacteria and cyanobacteria, making you have to treat more and have boil orders and private well impacts. The panel also talked about the impacts of drought that they're experiencing and the later ice in and earlier ice out that can also affect bacteria in surface water systems. And then the changes to water temperature can increase the impacts to more nutrients or oxygen and resulting in a decrease in water quality. And then we are seeing some saltwater intrusion in coastal systems due to that sea level rise coming up and over pumping in some systems. So now we have poll question number 2. Pierce?
Okay, so has your facility experienced impacts? To select one of the following: flooding, power outages, drought, or water quality issues. Please enter your selection. Okay, so looks like the drought is the big winner here, followed by water quality issues. Interesting, given the weather conditions we've had that have been so dry over the last, almost the last year or so. But great, thanks for responding to the poll. Back to Sherry.
Awesome. Yeah, thank you. All right, so now as you think forward, what are our projected future situations going to look like? And I'm going to share some data from you from those climate assessments. But first, let me orient you to this next bit of slides. So on the left, you're going to see graphs, or sometimes they're up and down, but you'll see southern New Hampshire versus northern New Hampshire. Southern New Hampshire is from Plymouth south. Northern New Hampshire is from Plymouth north. There's about 17 miles of overlap there, just to make sure that Cameron and his team captured all the data. I want to point out that the scales are different in each of the regions. So what you want to do is pick your region where you are and pay attention to the data for your region. You can compare them, sure, but just recognize that the scales are different. The gray is the historical, so what it was like in that 30-year period between 1980 and 2009. The blue is a lower emission scenario where we're trying to reduce our carbon dioxide and other greenhouse gas emissions. And the red is a high emission scenario where we're going with business as usual, not doing enough to decrease our carbon dioxide emissions. And so we are in a high emission scenario right now, so you can really focus on the red bars. Okay, so you'll see a number of graphs coming up here with this same color scheme. So this one is about extreme heat and looking at the average number of days over 90 degrees per year. You can see in the south, we're going to have more than in the north because that's the way it goes with geography. But what I want to point out, here we are in this 30-year period in the high emission scenario, and in southern New Hampshire, we would be expected to see about 12 days maybe above 90 degrees. But remember I mentioned that Manchester already saw 30 days above 90 degrees. So these projections were completed in 2014, and we're a little ahead of what they thought then. But by the end of the century, we could see almost a whole summer over 90 degrees in southern New Hampshire and a good month and a half over 90 degrees in northern New Hampshire. So it's getting hotter. In terms of the future growing season, if you're a gardener, you might be excited because the growing season is projected to lengthen by about 2 weeks or 5 weeks, depending on the scenario in the region. But because we're going to have these hotter temperatures and reduced chilling at night, and coupled with extreme precipitation or drought, it's likely going to increase in a decrease in crop yields. In terms of future precipitation, both regions of the state are expected to see an increase in annual precipitation from 17 to 20% by the end of the century. And this increase in precipitation, results in runoff, erosion, flooding, bad water quality. So we have to get prepared. So we're going to get warmer and we're going to get wetter. And this is a sad slide if you like to play outside in the winter. Historically, in southern New Hampshire, we used to have about 105 days of snow cover, and in northern New Hampshire, we had about 140 days of snow cover. But by the end of the century, in southern New Hampshire, we could only have about 52 days and about 100 days in the north. So those of us who live in southern New Hampshire and enjoy cross-country skiing or perhaps snowmobiling, you're probably going to have to go north to be able to enjoy those activities. And some of the ski areas may even have to close down because if it's not getting cold enough at night, even if they make snow, they're not going to be able to have it last for good use. So we're going to see change in our snow-covered days as we move out into the future. And this is a busy graph, but I'll break it down for you. These 9 scenarios are probabilities of what we might see for sea level rise. But if we assume that global greenhouse gas emissions begin declining by mid-century, we're likely to see a 0.5 foot to 1.3 feet of sea level rise by 2050 and 1 to about 3 feet by 2100. But it could be much higher if the greenhouse gases continue increasing or if ice sheet melt accelerates. And we're seeing greenhouse gases increasing and we're seeing ice sheet ice sheet melt accelerate. So we could be in these the areas that are more of a high probability. And the area I'm looking at is right in here, this blue area, low end of likely range central estimate. So it looks a little complicated, but basically, if we don't do anything to change our greenhouse gas emissions, we're going to see more sea level rise. And what we know is sea levels are going to continue to rise for centuries. And because our coast is significantly impacted by nor'easters and hurricanes, they drive water towards the land. And so we have more storm surge where we're getting inundated for longer periods of time and farther inland. And I mentioned this earlier, that groundwater rises when sea level rise. So let's look at this saltwater freshwater interface. And as the sea level is rising up, it's pushing the groundwater up to the surface as well. And we can expect to see from 1 to 5 feet of groundwater rise as far as 3 miles inland from tidal shorelines. And this amount of groundwater rise isn't uniform or linear with distance from the coast. It depends on a lot of things like the local hydrogeology, the proximity to streams and wetlands, the distance from the coast, but also groundwater pumping. If you're doing a lot of groundwater pumping, you might suck that salt water right up into your system. And this groundwater rise is going to impact a lot of infrastructure, including roads, underground storage tanks, drinking water wells, septic systems, landfills. So we're paying close attention to this, and we're doing active research on what we can expect for groundwater rise. And then there's these exacerbating issues, right? We're going to see an increase in population due to displaced people. People maybe don't want to live in the Northwest anymore because of the fires, or they can't live in Puerto Rico because of the hurricanes. So they're coming to New Hampshire because we have space and we have water. So as we see more people, we're going to see more development. As we see more development, we're going to see more pavement. More pavement causes more runoff. We're going to see more homes built in risky areas, putting people in harm's way. And as we've all talked about, our infrastructure is already old and undersized for our current weather conditions. And so we need to be mindful of making changes to our infrastructure to reflect current conditions. But then there's that issue of federal funding, and it's looking positive now based on Brandon and Commissioner Scott's remarks. But there's also still some politics around this issue, and I'm sure you could think of other exacerbating issues if we were able to have a conversation together. So we need to do both. We need to reduce our fossil fuel use to mitigate climate change. If we are more efficient or have renewables, it saves us money now and into the future, and it will also reduce the amount we have to adapt to. And then we have to start adaptation. And people on the panel are there, and every proactive adaptation step is really important, including changes to your municipal policies, your operations, your capital investments. And for every dollar invested now, it will save $7 in recovery. So it's smart to do what our panelists were talking about and be proactive in their adaptation efforts. So it's not all doom and gloom, because we've met these types of environmental challenges in the past. There was a situation with smog coming from vehicles, and what the solution was a national effort to require catalytic converters on all vehicles, and it worked. Smog has been reduced by 30 to 50%. We don't have an issue with smog in New Hampshire that's persistent anymore. Remember the hole in the ozone layer? There was an international agreement to reduce the use and phase out chlorofluorocarbons, or CFCs, and now CFCs have pretty much all been eliminated, and the ozone layer is slowly rebounding. And remember acid rain? We don't really talk about it anymore because the solution worked. The solution was a market-based program, a cap and trade program for regulating utility sulfur dioxide emissions. The utilities in the Midwest were emitting a lot of sulfur dioxide that would then be transported to our region and turn into sulfuric acid and nitric acid that went into the waters and impacted our forests and our lakes. This market-based program was very effective. The acid rain emissions were cut by 50%. Our forests are rebounding and our lakes are slowly recovering. And this market-based program is also what is used in the Regional Greenhouse Gas Initiative that Commissioner Scott mentioned in his slides. The Regional Greenhouse Gas Initiative is a cap and trade or market-based program for regulating carbon dioxide emissions. It is also the same program that was proposed by President Obama in the Clean Power Plan. So there is a method to manage the carbon dioxide going into our atmosphere. We just have to get it put through our political system so we can have a market-based program for carbon dioxide. It works. So to conclude, we've got to make these connections. We have to understand that taxpayers are going to be charged with $500 billion this decade and trillions more into the future unless we mitigate the impacts of climate change. We can't ignore the impact of climate change on our public health, our environment, and our economy, and these lessons will continue to be taught until they are learned. So I want to help you to connect the dots so that you understand what you're seeing around you are examples of a changing climate, and that you have the power to help to make the changes, whether it's with your drinking water system or in your own personal life, so that we don't keep contributing to these climate change issues. And so we need to work together, right? All of us here today need to work together and have shared voices and let our decision makers know that we want action on this topic. And now we have our last poll question. Pierce?
Right, so climate change is real and it is caused by us, but can we fix it? Yes, we can by one of the following: reducing our fossil fuel use, using energy more efficiently, working together to make the necessary changes, or all of the above. Okay, so all the above, yes, I would say that's pretty true. It's going to take all of those things and more. Sherry, thanks. I think you have one more slide, or is that?
I do, and I fully recognize that I'm the only thing between this audience and lunch, but if anyone has any questions, I'm happy to receive them now. Thank you.
It does. Thanks again, Sherry. It was great. Do have a couple of questions, and I'll turn it to Liz, who I believe has those questions. Liz?
Yep. Hi, Sherry. We have a few for you. The first one, what do you see as the timeline we have to bring the carbon dioxide level back down to 300 parts per billion?
So that's an interesting question, and it's been brought up by the IPCC, and a few years ago, the Intergovernmental Panel on Climate Change is the IPCC. And a few years ago, they said that we really need to move forward to bring our emissions down by around 2040. But there's some debate around that, and so I think we need to just keep our eye on the prize and to keep working on reducing our CO2 emissions and reducing our use of fossil fuel.
Okay, next question. What are your recommendations to build community and personal resilience to climate change?
Well, first, pay attention, right? Pay attention to storms. If there's going to be a storm, prepare yourself. For instance, I have a private well and my own septic system, and when I know there's going to be a storm with potential power outages, I have jugs in my basement that I fill up with water, because if I lose power, I can't flush and I can't drink water. So we prepare by doing that. So you pay attention to what's going on around you to prepare yourself so that your household is safe, your family is safe. And then if you're working at a water system, you also do many of the things that the panelists said today. You do your asset management, you know what you have, you try to keep thinking forward with your capital improvement plan. And if you're a municipal person who's involved in like a planning board or something, you start to think about your policies and you think about what is working and what isn't. Should we have better buffers around our wetlands and our rivers and enforce those buffers, because our wetlands and our rivers and our streams help to protect us from flooding? So you just pay attention and think about what's going on around you, and then bring voice to it, right? Have that conversation with your father-in-law at dinner. Talk to people about this issue and help them to understand. That's what this presentation is intended to do, to help you make the connections about what we're seeing around us and how they are indicators of climate change. And if you have any questions, my contact information is here. I'm happy to talk to you after this event today.
Thank you. Next question. Any thought how the growth, life cycle, and abundance of shellfish and saltwater flora acting as a carbon dioxide sink might have on climate and ocean temperatures?
It's really important, especially our salt marshes and our forests. They do absorb carbon dioxide, and our salt marshes are, you can't imagine how thick the layer is in those salt marshes. And so they all hold carbon dioxide and keep it inside them. And so we want to retain our natural landscapes, such as our salt marshes and our forests, because they are a carbon sink and they can help to decrease the amount of warming that we're seeing. But with salt marshes, you have to really pay attention to what's upland of the salt marsh, because as sea level comes up, the salt marsh can get inundated unless it can move inland or adjust to the sea level rise that's coming. So in coastal New Hampshire, we do a lot of thought and research and action around being sure that salt marshes have the ability to migrate inland as sea levels come up. So yes, there's a lot that is within a natural system that can retain carbon dioxide, and also a natural system is a more resilient system. And so if we can keep intact ecosystems in place, they can definitely help to adapt and decrease the amount of climate change we are experiencing.
Great. And one more question, Sherry. This is a global societal issue. How do we go beyond our borders? How much do outside decisions impact our country, our state, and our local community?
A lot. It is a global issue for sure, but we all have to take steps, right? And often the United States can be a driver of this by leading by example. And we're in a good situation right now to be able to lead by example. You've all heard about the Paris Accord. The Paris Accord sets goals for us to achieve. And it's not just the United States, it's every country on the planet. And we definitely all need to work together and reach across our oceans to support each other and help each other in doing the things that we need to do as a global community. It's a big issue. I'm not unaware of that, but we all have to work on it. And many countries are, and the United States is poised to really move forward at this point in time.
Great. Another question came in. What are your thoughts about the reduction of the use of salt during the winter?
I think it's a great idea, because salt is really difficult on our receiving waters and our receiving lands, and it can impact drinking water wells. But that's a great question, because now with the winters warming, we see a lot more icy conditions on the roads. And so I don't have data on this, but there may even be an increase in the use of salt on roads right now, because people still want to go wherever they want to go, and they want to go fast. And so people continue to drive in challenging conditions, and it's the DOT's job to be sure that the roads are safe. So maybe we all could think about our behavior, and if you don't have to go out in the middle of the storm, don't. And don't demand that you get to go 50 miles an hour on a road that's covered in ice. Slow it down. So we can change our behavior, which could also drive demand or make less demand for DOT to have to salt, and our local municipal roads as well, to salt as much. But I think it would be great if we could use less salt, but we also have to keep people safe. So we need to manage conditions, we need to manage expectations, and we need to adjust our behaviors, right? Another adaptation.
Great. We did have a couple questions, Sherry, about people interested in possibly getting a link to your PowerPoint presentation. Is that something they should just contact you for?
Yeah, I think that would be the best way, unless, are you guys organizing any of that with other presentations through this conference?
We can and have in the past put presentations up on our website, so we can do that as well. So either sending it out as a PDF or putting it online, whichever works. We'll follow up after the meeting.
Sure, and if anybody has questions, you can be in touch with me. Thank you.